This is Module 3.2, In-Flight Operations. In our flight preparation, we left the sonde operating off the battery and the ground equipment showing ready for sonde release. Confirm that the telemetry indicator shows a good signal. Ensure the PTU data are being received properly. Bend the sensor boom so it snaps into the holder. Visually inspect the sonde to confirm everything is secure. Now we're ready for release. As a safety measure, a staff working alone alarm is pre-programmed for release to take place at minute 15 and will automatically start a countdown timer and will sound an alarm if the technician hasn't safely returned to the office by minute 35. 5 or 10 minutes before release, take the radiosonde and go to the balloon shed. As you approach, you want to pay attention to conditions. Is there any debris or bird droppings on the stairs or ramps that might leave a slip hazard? Is there any debris on or around the ramps that might pose a trip hazard and affect the balloon release? Attach the sonde to the balloon by inserting the unwinder into the folded over balloon neck. Depending on the wind direction, select and partially open the appropriate overhead door and walk down the ramp to do a hazard check. Is the ramp secure and free of slip hazards? Is the ground clear of trip hazards? Is there wildlife around the release area or under the ramp or stairs? Is there thunderstorm activity nearby? If so, you'd postpone your release until they've gone by. Are there any low-flying aircraft? If so, you'd postpone your release until they're clear of the area. In high winds, you also need to scout out the turbulent zones and pick your release point to minimize the risk of damaging the balloon. If everything looks good, open the overhead door all the way and prepare for release. The release should occur at minute 15, but it's possible that events like aircraft, wildlife, or weather conditions will delay the release. The official release window is minute 15 to 29. It's important to not release earlier than minute 15, as the software is configured to treat any release before minute 15 as having occurred the previous hour. If the release occurs after minute 29, the release is considered late and you must provide an explanation. Holding the balloon neck with one hand and the radiosonde with the other hand, walk down the ramp. In light winds, you can just walk out. In windy weather, you may have to run to keep up with the balloon and minimize any stretching, and you also may have to run to get through the turbulent zone without damaging the balloon. When you're clear of the building, raise both arms and let go. Close the overhead door and return to the operations building. Hit the space bar to acknowledge your safe return to the office. The sounding software will have detected the release and will display the data entry window for the surface weather observation. Enter the surface data values from the AWOS display and click Next. The flight will now continue. Monitor the flight performance on either the EDT window at the bottom, or you could view the graphical display by clicking the profile icon. The first obstacle to a successful flight is icing. In dry conditions, it's not a problem, but if the balloon is ascending in rain or snow, it can start to accumulate a layer of ice when it reaches freezing temperatures, and sometimes that layer of ice can become heavy enough to force the balloon back down. When this happens, the software will detect the descending balloon and end the flight. So if you release in rainy weather, the first thing you must watch is the balloon's behavior as it goes through the level where the temperature equals 0 Celsius, the freezing level. When the sonde continues to ascend through -3 Celsius, you're usually safely through the freezing layer. The sonde will typically reach a pressure of 400 hectopascals in about 25 minutes, and that's the minimum performance target used by Environment Canada. If the sonde fails to reach 400 hectopascals, either due to a balloon burst or instrument failure, then a second attempt should be made. After about an hour, when the flight has data above 100 hectopascals, the software will produce 3 data messages, the US, the UK, and the UG, for transmission. The Wind file software will automatically detect the messages and move them to the outgoing messages folder. The WinXPPP software will then automatically send the outgoing messages to the Maritime Weather Center. If you wish, you can confirm the messages are transmitted properly by using the WinXPPP display menu to examine the log. To confirm the messages are properly received at the Maritime Weather Center, use the Anacom computer and issue the macro command UA to see all upper air messages received in the past 6 hours. About 2 hours after release, or when the balloon bursts, a second set of 3 messages, the UE, UL, and UQ, will be generated and transmitted. Again, use the Anacom UA command to display all Sable Island messages received on the mainland. Sometimes the second set of messages has incomplete data and corrected messages are sent when the flight ends. These are the UE core, the UL core, and the UQ core. Once again, use Anacom to confirm the data messages were properly filed. Let's review the timing of the data messages. This flight was released at 23:15 Zulu. It took just over an hour to get data above 100 hectopascals, and the first set of messages were computed and sent. The flight often ends around 0100 Zulu when the UE, UL, and UQ are sent with all the data above 100 hectopascals. But in this ascent, the balloon was still going at 0115 Zulu. So a preliminary set of messages was automatically sent. And then corrective messages with complete data were sent at the end of the flight. The software will detect when the flight ends, either due to increasing pressure, such as a balloon burst or balloon forced down by icing, instrument failure, loss of signal, or excessive missing data. When either of these events occurs, the software will announce that it's terminating the sounding. When the software issues the request to archive process, click Next. When the end-of-flight sequence is completed, the software announces sounding ready for termination. Click Next to close the sounding software. The flight is now completed, the data is all successfully transmitted to regional headquarters, and the flight data is now archived on the hard drive. Turn off the power to the GC25 test set, the MW31 sounding receiver, and the computer. Let's summarize the fundamental process after release. Release at minute 15. If for some reason your release is delayed beyond minute 29, you must provide an explanation for the late release. After release, return to the office and cancel the staff alarm. Enter the release data, the pressure, temperature, humidity, wind speed, and direction. In rainy weather, confirm the flight gets safely through the freezing level. After about 25 minutes, confirm the sonde reaches 400 hectopascals. After about 75 minutes, confirm the messages are sent at 70 hectopascals. After about 120 minutes, confirm the messages are sent at termination. When the flight ends, archive the data by clicking Next, Next, Next. Then turn off the ground equipment. Special procedures. Sometimes the release isn't successful. In high winds, the balloon might get broken during the release attempt. If the balloon breaks before you let go of the sonde, you may be able to still use the sonde. Go to the office and confirm you still have good telemetry and stable raw PTU data. If not, disconnect the battery and prepare another sonde. Fill another balloon right away and release right away. If the balloon was broken after you let go of the sonde and the sonde has hit the ground, even if you recover the sonde and it's still transmitting fine, it's best to not trust it after any hard impact, and instead prepare another sonde and another balloon. Disconnect the battery from the sonde to stop it from transmitting. Turn off the ground equipment, then get another sonde and start the preparation from the beginning. Fill another balloon and release as soon as possible. Sometimes the release seems to go perfectly, but when you return to the office, the software is not requesting the release weather data. What's happened is that the software failed to detect that the release has happened. You can wait another couple of minutes to see if it'll figure it out, but most likely it's too late already. Shut down the software, the computer, the MW31 and the GC25. Prepare another balloon and prepare another sonde. Since there's a transmitting radiosonde already floating through the atmosphere, ensure you change the frequency of your second sonde by at least 1 MHz to avoid any radio interference. If the flight ends before 400 hectopascals, ensure any messages have been sent and archive the flight data as normal. Shut down the MW31, the GC25 and the computer. If this is already a second attempt, then call it a day. No third attempt should be made. But if this is the first flight attempt, then a second release should be made. Get a new sonde and start over again. When you get to the sonde properties screen, change the default frequency of the sonde by at least 1 MHz from the first sonde, just to avoid radio interference. Prepare a second balloon. If the first balloon was forced down by icing, add 400 grams of extra lift. Release as soon as possible. If you have a loss of data in flight, for example, if humidity data goes missing during the ascent, no corrective action is needed. If wind data goes missing during the ascent, no corrective action is needed. If either temperature or pressure data go missing during the flight, the system will attempt to interpolate through the missing data. But if this is unsuccessful or if there's too much missing data, the flight will simply terminate. If the flight terminates before 400 hectopascals, then, if time permits, you should attempt a second release. Sometimes, one or more messages aren't received properly at the weather center. The missing messages should be sent again. On the sounding software, click on the message icon. On the Available Messages tab, select the messages that are missing, click Code to create the messages again. Then, click on the Coded Messages tab and select Send. The messages will be sent again. This is the end of in-flight procedures.